guys. Okay, we're going to learn today how to do the problems using Pascal's principle. So what you all need to do is watch as we go and fill in your own if you print it out. If not, you can just do it on a regular sheet of notebook paper. But follow the steps that I'm going to show you. I'm going to show you neat little math tricks to help you solve for the unknown variables, since there are 4 different variables in the formula, okay? And this is a nice little trick you can do anytime you have one ratio equal to another ratio. You can use this method. Doesn't have to be for physical science. It can be for anything. Okay, so we're looking at a hydraulic system here that uses Pascal's principle. You have a dentist chair. Who hasn't been in a dentist chair before? They go up and down. So here's how. A dentist chair makes use of Pascal's principle to move patients up and down. Together, the chair and the patient exert a downward force of 2,269 newtons. Okay, so guys, that is the weight of the chair and the person together. That's what we want to lift. That's the force we want to exert upward on the person and the chair. Okay? So this, even though that's what they're pushing down with, that's what we want to exert upward with our hydraulic system. So that's the amount of force we want to get out of the system, because I guarantee you none of us could lift that much, okay? So the force we want to get out of the system is 2,269 newtons. So on step 1, we're going to write down what we know and what we're looking for, okay? The chair is attached to a large piston with an area of 1,221 centimeters squared. Now, if this is the large piston, it's the output piston, and it will be under the chair and the person and push up on them for us, okay? So the output piston is 1,221 centimeters squared, okay? Now, and here there we go, underline that. To move the chair up, a pump applies a force to a small piston with an area of 88.12 centimeters squared. So the small piston is what you push on with the pump, okay? And it has this smaller area. Now that's something you want to remember. The input area piston is always the smaller of the two. The output will be the larger, and the input will always be the smaller, okay? So here, write that down right here if you can't remember, all right? So remember, A out should always be larger than A in, okay? This should be the small one that you push on. And then the hydraulic system uses the larger output piston to push up on the object to be moved, okay? All right, so now, what are we looking for? We want to know what force must be exerted on this small piston. What force must we exert or put into the system in order to get out this much force, okay? Now, Pascal gave us a clue. He said the pressure is undiminished throughout. So when we exert a force on this area, we exert a pressure into the hydraulic system. Well, that pressure is transferred through the fluid undiminished. So a larger air output area and a larger force would give us the output pressure. But these two pressures must be equal because Pascal said the pressure itself is undiminished, okay? So the ratio of these two must be equal to the ratio of these two. Now, if you'll remember, and I'll write it over here to the side, Pressure is force per unit area, okay? That's what pressure is. So the pressure in would be the force in over the input area, and the force we get out divided by the output area, the area of the output piston, okay? Now, I want you to think. This is the one that we want to find right here, the input force. But how do we get it by itself? We're dividing it by the input area. Well, there's a neat little math process you can use when you have one ratio set equal to another ratio. Okay? Here's the first step you take. All right? The first step you take is you're going to cross multiply both sides. I don't know if they still teach this in algebra and math, but it is a handy dandy little tool. So what we're going to do is we're going to cross multiply. So if I do that here, I get Fn times A out. So I write that down first. Fn times A out. Okay? We're going to multiply those two. And if you don't know, the dot just means multiply the two. It's shorthand for doing a times. Okay? Now, we've done those two. Now let's cross multiply these two. Cross it over and you get F out times A in. So we've cross multiplied both sides and here we go. We've got this now. Now remember, we're still wanting this one. Oh, but now it's going to be a lot easier because the next part of the process is simple. Okay, let me get my little cute arrow right here. So next, now that we've cross multiplied, we're going to divide to get rid of the unwanted variable and leave behind the one we want. So we cross multiply and then we're going to divide. All right, so we're going to divide this side by A out, and we're going to divide this side by A out. They cancel right here, and that leaves behind what we want equals F out times A in over A out. So cross multiply, divide, cross multiply, divide. And that will isolate the variable you want. And that will work every single time that you have two ratios equal to each other. So see, it doesn't have to be just for science. It can be in your math classes too. Cross multiply, divide. Okay? And you'll get left with whichever one you want left behind. Okay? We'll do another one in a minute, but let's finish this first. So we're going to use this. Now right here on step 3, we are going to plug and chug, okay? So we know that the force we want to put in should be the same as the force that we get out, which is, and I thought it was 1,000, but I think that's the area. Hang on, I want to make sure I get the right numbers in. The force out, which is 2,269, times the area in, the input area of the piston, the input piston rather, and we're going to divide that by the area of the output piston, which was, that's the 1,221 centimeters squared. Now notice, from top to bottom, you have centimeters squared over centimeters squared, so they cancel. That's going to leave behind newtons of force, which is exactly what you want because that's what you're measuring. So now, if you stick this in your calculator, and you might want to double check and make sure you get the actual same answer I'm getting, I got that Fn, the force we have to push on this smaller input piston with, would be 163.8 newtons. Actually, I think it was 163.75, but I rounded it to 0.8 because we don't need to keep writing out tons of decimal places. Okay, so there we go. All right, if you put in 163.8 newtons, you'll get out 200 and 269 newtons of force, and that will lift the dentist chair with a person in it. Okay? All right, let's look at one more real quick. This one says you have an engineering student who wants to build her own hydraulic, typo, look at that. Not hydraulic pump to lift an 1,815 Newton crate. So we want to lift the weight of this crate. This is the force we want to get out of the system. To lift that crate, it's got to exert 1,815 newtons on the crate. So we know the force out. All right, if we want the system to lift the crate, it needs to put out a force of 1,815 newtons. Okay, now it says the pump will have 2 pistons connected via a fluid chamber. The student calculates that she will be able to exert 442 newtons of force. Okay, now that's what she's doing. So she's putting that into the system. So we know the force into the system needs to be 442 newtons. And she's going to exert it on the smaller piston, the input piston, which has an area of 50.2 centimeters. So we know the input area is 50.2 centimeters squared. We want to know what area must the large piston, that would be the output piston, need to be to exert the desired force. So we want what size output piston does she need to create for her chambers, for her one side of her chamber of fluid, so that she can lift that crate. Okay? All right, so we've got our knowns and our unknown. Let's write our formula. Okay, now, do we need to rewrite this? Not necessarily. Let's just rewrite this part right here. Okay? We know the 2 pressures must be equal. So the force in over the area in equals the force out over the out piston area. Okay, the output piston area. There we go. Now, what is our trick that we're going to use? You like my little funky arrows? Okay. There we go. We're going to cross multiply. All right, these 2 sides, so let's try it. AN times F out for this side. Then your equal sign. And then these 2. FN times A out. Okay, so we've cross multiplied. Now we want the out area. Here it is. Doesn't matter that it's on the right side. Don't worry about that. So the out area is the one we want. All right. So we want to get rid of the other variable. So what's the second part after we cross multiply? Now, if you look back up at the former example, we're going to divide. All right. What are we going to divide by? The thing we don't want. We don't want the force in. We want the area out. So we're going to divide both sides by this. Those 2 cancel. And now, what have we got left? We've got left the output area. You can put it on the left side now and put the other stuff on the right. The output area equals, because that divided out, AN times F out over FN, which we divided by. There we go. That's what we're going to use. So now we come down here, we're going to plug and chug. So the output area piston that she needs to create for her system would be the area in, which was, there it is, 50.2 centimeters squared, times the force that we want to get out of the system, 1815 newtons, divided by the force that we want to put in, 442 newtons. Notice this case, the newtons cancel and leaves behind centimeters squared, which is what area is measured in. So we're doing it right. Okay, so now if you say 50.2 times 1815, then divide that by 442, you should get an answer for the area of the output piston of 206 centimeters squared. Now, how do we know that that's probably right? Well, look at your input area. Remember, we said the output area is always greater than the input area. And in this case, it most certainly is. In fact, the output area is 4 times bigger than the input area. Kind of nice, isn't it? Okay? So that means we get out 4 times the force too, by the way. All right? If you know how many times bigger your output area is than your input area, then you know how many times bigger your output force will be from your input force. Since these two, this one's 4 times bigger than this one, this one's 4 times bigger than that one. How about that? Okay? So, there we go. All right, so if you use this process of cross multiply and then divide by the one that you don't want to leave behind the one you do, you'll be fine. Just set it up every time, cross multiply so that you get one line of variables, then make sure you know which one you want and divide by the one you don't want so that it goes to the other side, okay? Because what you do to one side, you got to do to the other to maintain equality, okay? So this is a lovely little trick to use when you have two ratios set equal to each other. Cross multiply and then divide, okay? Then you can plug and chug and boom, you'll be done. You've only got 4 problems, 1 on this side and 3 on the other sheet. Now, if you want to print out the document and write on it, you can. You most certainly can. But you can also do it on your own paper. But please remember, you must show your work in order to get full credit for this. All right? There are no shortcuts here, children. Must show work. Okay? That's what scientists have to do out in the real life. That's what you have to do here to get full credit, okay? All right, see what you can do with it. If you have any questions, please feel free to message me. Okay, bye-bye.